Okay, before we get started, I'm giving you a little handout today that will go with your notes. That's just going to make some things a little bit easier. And so you'll see when this comes up, and you'll just fill this in when it is time. So just take this and put it with your notes for now. All right, so today we are looking at what all changes and how we determine changes in equilibrium price and changes in equilibrium quantity when supply and demand or both change. So we talked about equilibrium yesterday. We know that that is that point where supply meets demand, where quantity supplied equals quantity demanded. That is our equilibrium point. That tells us the equilibrium price, the equilibrium quantity, and what we sometimes might call that the market equilibrium. And we can find that either with a demand and supply schedule. We can find, okay, where do those two things meet? You know, at what quantity do supply and demand meet up in the same place? We can see that graphically when we graph those kind of things, and we find that X, and the point where the X, comes together, that point in the center, is going to be that equilibrium point on our graph. But now we're going to look at, okay, what happens when the curves shift? Because that's what we've been practicing with these curves individually. We've looked at the different things that make demand curve shift. We looked at the things that make supply curve shift. Now we're going to talk about what that does to equilibrium price and quantity, okay? And all of this makes sense in a practical way. So you really, our temptation sometimes here is to try to memorize, okay, demand does this, and you really don't have to quite so much because it'll just make sense, okay? It will just make sense. If you think about it in a practical situation, in situations that you know to be true in your own life, supply and demand are very, very relevant to us. We don't have a hard time finding real-world examples of this at all. So one characteristic of all of this, or one phenomenon that will take place, is if demand increases, okay, equilibrium price and equilibrium quantity will both go up. Okay, so if demand increases, there's a shift in demand. Taste and preferences, for example, more people want that particular good because it has become more popular, fad. Medical research has suggested that this ingredient is going to cause you to let you lose weight or something like that. Then the equilibrium price and quantity both rise. We all know that because when everybody is after something, everybody wants the latest iPhone. Everybody wants the latest new TikTok craze, whether that's a makeup product or a pair of shoes. What happens to the price of those things? They end up going up because everybody wants them and the price starts to go up. Also, the equilibrium quantity is going to rise. That makes sense because if more people are demanding it, then the quantity demanded is going to go up. Okay? Oops. When the demand decreases, obviously, equilibrium price and equilibrium quantity fall. So when there's a shifter of demand, again, something other than price, maybe there's a study showing that this chemical in this food causes cancer. Maybe there is we see this a lot with, a celebrity that's once endorsed a product and then they get caught doing something bad and all that kind of thing, and people want to disassociate from that person. All of a sudden people don't want to buy that particular product anymore. That is going to cause the equilibrium price and the equilibrium quantity to fall. Okay, and once again, we see examples of this all the time. When first when some hot new product comes out, everybody wants it. It's super expensive. After time goes on, people get kind of over it. Maybe it's not the hottest next best thing anymore. Maybe there's new fads that have overtaken it, and now you go into the store and what do you notice about that same thing? The price is lower. They put it on sale. It's on clearance. All those kind of things. We are demanding less of it, and so the equilibrium quantity is going to fall. However, we need to know how to graph that. And so not only is it, you don't really have to go through and memorize all this stuff word for word because you can think it through. You know that if the demand for something is increasing, the price is going to go up too. we also can graph it out, okay? And this is the phrase you're going to hear me say a lot, and that is, when in doubt, graph it out. If you are not sure which way things are supposed to go, and that does get more complex when they're both shifting, when supply and demand are both shifting, just graph it out, okay? So let's draw a little graph. I recommend that you draw a graph in your notes. You don't have to necessarily make it for cotton like this one, but draw yourself a little supply and demand model right here, okay? Because then you're practicing doing that. So we should have our price on the left-hand side, on that vertical axis. We should have quantity, a Q, on the horizontal axis. Make sure you're always labeling every axis, every curve, okay? Not quite finished grading the demand graphing worksheets. I'll have those done by the end of class today. But there were a handful of you that did not label your second curves, just put the line, didn't put D or 2 or whatever. Make sure you're doing that. So you have your downward sloping demand curve, label it D or D1, representing the law of demand. As price goes down, the quantity demanded goes up, so forth, so on. And then an upward sloping supply curve. Then we should have our equilibrium point, all right, which is labeled here as E1 for equilibrium. But most importantly, we need to make sure that we draw a little dotted line down from here to here, and that's our equilibrium quantity. We're labeling that Q1 here, and out to the side, our price, P1. Okay, make sure we always do that. Whenever you have to draw a supply and demand model of any kind, it should always be what you draw first, just not necessarily labeled as cotton. It can just be anything, okay? All right, so let's assume that something now in the market has changed. There has been an increase in demand, okay? So cotton demand has increased. Maybe there has been a research that shows that cotton fabrics are better for your skin. Hello? Yes. So maybe there's been a study that shows, cotton is better for your skin, and all the other products are going to cause skin irritation or cancer or something like that. So demand has increased. Which way does my demand curve go if it's increasing? It shifts to the right. So I'm going to draw in a new demand curve shifted over to the right. I'm going to label that D2. Okay, that shows my increase in demand. And so now I have a new equilibrium price and equilibrium quantity. So there's my new equilibrium point. All right, supply now meets demand here because demand has changed. So now I have a new quantity. I will go down, draw a little dotted line down to Q2 in this case. Notice again the labeling, okay? If I do not go in and label this as D1, D2, S1, S2 respectively, Q2, all that kind of thing, then you're not going to be showing, you won't be correctly showing which one is which. You're not correctly showing the change. So it is not optional to not put your letters and to not, if you're showing shifts, to not put a 1 or a 2 or whatever is needed to differentiate between the original one and the new one, okay? So we see here that we have a new equilibrium quantity. Is it higher or lower than the original one? It is higher. Equilibrium quantity went up, like we just said. We have a new equilibrium price. Is it higher or lower? Higher. So we can graphically demonstrate that an increase in demand leads to an increase in the equilibrium price and an increase in the equilibrium quantity. Okay? All right, now let's talk about supply. We looked before or earlier at supply. We learned the different things that shift the supply curve. All right, perhaps there is a change in the price of the inputs. That's a big one that you're probably going to work with the most. Maybe the price of labor has gone up. The price of whatever it is they use has gone down, whatever it is. Maybe there's more producers. All those things, know your shifters. So some outside factor other than price has affected the supply curve. So if supply decreases, that means the equilibrium price rises and equilibrium quantity falls. So they will move in opposite directions. So when it's demand, they're usually going to move in the same direction, equilibrium price and quantity. If it is supply, they will move in opposite directions. We could probably come up with 100 examples of seeing this kind of thing happen, particularly in the past couple of years, because there have been lots and lots of hiccups to the supply chain. We keep hearing it all over again, supply chain problems, supply chain's jacked up, and we have shortages of all kind of things. We have shortages of baby formula. We have shortages of you name it. There have been shortages of one thing or another, okay, because so much of the supply chain has been interrupted by overseas stuff being shut down due to COVID, ships getting blocked in the Suez Canal, all that kind of stuff. And what has happened to the price then when all those shortages have occurred? Price has gone up. Okay, so equilibrium price is going to go up, and of course the quantity goes down. If there's less being supplied to the market, then that equilibrium quantity is going to have to go down. Vice versa, if supply were to increase for some reason, maybe there's more producers of something, the equilibrium price is going to fall, and the equilibrium quantity is going to rise. We see this all the time. Oftentimes when a brand new product comes out, you usually just have like one company that makes it, it's real expensive. For example, when iPhones first came out, that was the very first smartphone, okay? Now, not to say iPhones are cheap now, because they're not. But they were the only one that made a phone like that. Okay, super, super, super expensive. But as time goes on, what started to happen? Other companies started, Samsung came out with one, HTC, they all, everybody started catching on to the smartphone craze. Now you have more options, therefore an increase in the number of suppliers, market change, and the prices started to come down. Now again, those are still really expensive, and as technology improves, that kind of has something to do with it as well. But eventually we started to see more, and you can think of lots of different examples like that of, the knockoff brands that start to come around, increasing the supply, and then the price will start to fall, and of course the equilibrium quantity will rise. We can demonstrate that as well. Let's demonstrate that. So draw yourself real quick, be able to do this real quick, a supply and demand model. So we've got to have our L-shaped axes with price on the vertical and quantity on the horizontal. Downward sloping demand curve, which you can just label with a D. Upward sloping supply curve, which you label with an S, or in this case S1, because we're about to move it. And we have our equilibrium price over here, P1, and our equilibrium quantity, Q1. All right. Now let's assume there's been some kind of change to the supply. All right, but there's been a shifter taking place. In this case, let's say that it decreases. Okay, let's say, as we have seen, that lots of factories in China have had to shut down because of COVID. Okay, so that is a decrease in the number of producers, and that will decrease the supply. Which way do I move my curve if it's a decrease? Moves to the left. So I'm going to shift that supply curve over to the left in this case, label that S2. Now, obviously, I shouldn't have to say this, but if the supply was increasing, we move it the other way. So you've got to know which way it's supposed to go. So now, once again, I have a new equilibrium point. So now, supply and demand meet here. So I draw down a new quantity, Q2. I come over here. I have a new price, P2. And I notice that my new quantity, is it higher or lower than the original? In this case, it is lower. And my price, is it higher or lower than the original? It is higher. So supply decreased, okay? Factory shut down, so the price of all those goods went up, and the quantity went down. Again, if it were to go the other way, let's imagine for a second that it went the other way. Let's say there's an increase in the number of producers. A lot more companies said, hey, there's money to be made here. We want to supply cotton. Okay, that would put a supply curve there. All right, we'd have a new supply and demand equilibrium. Let's say, imagine maybe right there. That would cause the equilibrium quantity to go up and the price to go down. It would be lower than it was originally. Okay. All right. Now, let's talk about what happens when they both shift. Okay, so both of the shifters together. We're going to see this on the graph first, and then you're going to that's where you'll use your little chart that you've got there. Although, I will tell you, I really think the best way to do this is to graph it out. Okay, when you have simultaneous shifts, the best way to figure out where equilibrium price and equilibrium quantity go is to graph it out. If you try to memorize, if this does this and that does that, you're really kind of wasting your time. I'm going to tell you, I don't have it memorized. I graph it. Okay, every time I just graph it. And that's going to lead you to the answer. Okay. All right, so let's say that there is a shift in both. So here we have our original situation, our original market situation. We've got supply sloping upward, demand sloping downward. We have our original equilibrium point, price, and quantity. Okay, so let's say that there is an increase in demand as well as an increase in supply. So, well, supply is going to change too. I don't know which way it's going to go here in a second. But let's say there's an increase in demand. All right, something has happened. Maybe a celebrity has endorsed a product. This is cotton. Okay, so demand shifts to the right. All right. Let's say at the same time that there's a decrease in supply. All right, and again, whether or not it's increasing or decreasing, that's going to depend on the scenario you are given. Okay, so you're going to have to pay attention to that and know how to shift it either way. All right, so in this scenario that we're looking at for the sake of illustrating the point, we're saying that there's an increase in demand and a decrease in supply. All right, so a celebrity has endorsed cotton, but at the same time, maybe there was a disease that ate up a lot of the cotton crops in some places, and so we have a decrease in supply. Okay, so that means we have a new supply curve and a new demand curve. All right. All right, so that means we have a new equilibrium point right here. All right, so equilibrium price and quantity, did it go up or down? The price is up, and the demand, or excuse me, the quantity is also up. But that may not always be the case, okay? When you have these simultaneous shifts, it's going to depend over which one was the bigger shift, which one shifted the most, supply or demand, okay? Which is why memorizing it isn't all that effective, because a lot of times you're not going to know that information, but if you do, it's going to depend on which one it is. In this case, we saw demand increase and supply decrease. But notice that the demand increase was a lot bigger than the one in supply. Okay? How can I tell that it's a lot bigger? Yeah, there's a bigger gap. The vertical distance between those two curves is a lot wider. Okay? So in this case, we're saying that it was a really big change in demand. The change in supply was a lot less. So the change in the demand overpowered the change in supply. And thus we had the equilibrium price and quantity ended up where it did. But you show both shifts on your graph and figure out where it ends up. Okay, which one of those things clearly went up or down. And oftentimes you're going to find that one of them is unclear. Okay, so I'm going to graph that out for you in just a moment. Okay, all right. So now let's do another example. You don't necessarily have to write every single one of these down, but let's show a different example where we show basically the same thing happening, but in a different, different intensity. Okay, so this time we're going to see a bigger decrease in supply. So this time my supply decreased just like last time, and the demand also increased. But notice the difference here. What's different? This time the bigger shift was in supply. The vertical distance between those two supply curves is bigger than the vertical distance between the demand curves, okay? And let's take a look at what happened. So we had a smaller increase in demand, all right, maybe just a few more people want to buy cotton, and a larger decrease in supply. Lots and lots of cotton fields got destroyed because of a crop disease or something like that. All right, so now I have a new equilibrium point right here. So what happened to my equilibrium price? It went up. If you recall, it did last time too. But this time, what happened to the equilibrium quantity? It went down. Okay? So we can't just say, oh, every time there's a decrease in supply and increase in demand, this will always happen, because it's going to depend on the size of the shifts. It's going to depend on which one was bigger, which one overpowered the other. And oftentimes you won't even know that. So usually what's going to happen is that either the price or the quantity is going to be clear, and then the other one is going to be what we call ambiguous. What does that mean, ambiguous? Yeah, you can't really tell. But you can't really tell either way, all right? So in that example, so the purpose of looking at both of those is, one, to see how the shifting works, okay, how you find your new equilibrium, but also why, it's when you're just moving one of them, if you're just moving demand or you're just moving supply, it's sort of a guarantee that, price and quantity equilibrium price and equilibrium quantity are going to go up if demand goes up. They are going to go opposite ways if it's supply. But when it's both of them, it depends. Okay, notice basically the same thing, increase in demand, decrease in supply. But what happened to the equilibrium quantity was different in those two scenarios. And the varying factor there was the size of the shifts. Okay. All right. So now pull out your little chart. I'm going to give you an opportunity to write it all down. But once again, I think trying to memorize this is really not that effective, because, like I said, it depends on the size of the shifts. But we're going to write it down anyway. So you're writing down what's in those 4 boxes at the top. So this is what happens with our simultaneous shifts. So if supply increases and demand increases, the quantity is definitely going to go up in those cases. And if we graphed it out, we would clearly see that the equilibrium quantity would go up regardless of how we drew the curves, okay, as long as we drew them shifting in the correct direction. But the price will be ambiguous. It won't be able to be determined unless we know that this one shifted a lot and this one only shifted a little bit. And I'm going to graph all this out for you in a moment. In fact, I'll get ready to do that while you are writing that down. if the demand increases and the supply decreases. The price is definitely going to go up. We'll be able to clearly see that. But unless we know the size of the shifts, unless it tells us that this one shifted more than that one, then the quantity is going to be ambiguous. We won't be able to tell. If demand increases and supply increases, or excuse me, I'm at the third one there. If demand decreases and supply increases, the price will definitely go down, but the quantity will be ambiguous. And if demand decreases and supply decreases, the price is going to be ambiguous, and the quantity will go down. And it makes sense because, okay, if demand is decreasing, then that would mean the price of something's going to fall. But if supply is decreasing, well, that means the price is going to go up. You see, so you have two different opposing forces working there. So that's why you would need to know which one overpowers the other to know where you're going to end up in that kind of a situation. All right, I'm going to graph all these out for you. You can see, show you what we mean, what it looks like on a graph if it is in fact ambiguous. Okay. Thing here. Okay. So I'm going to show you graphing out what this looks like, okay? If you want to attempt one or two of these with me, you can, or you can just watch as I go through. So I'm going to start with, okay, if demand decreases and supply increases. I guess black's probably the easiest. We'll do it. Okay. So as always, I'm going to start like so. 1, P1. Okay, so that's how I begin. All right, now I'm going to show my demand increasing. So what am I going to do with my demand curve? I'm going to shift it to the right, D2. And my supply is also going to increase. So where am I going to move it? It's going to also move to the right, S2. All right, so demand and supply now intersect right there. So there's Q2. Okay, so clearly what happened to my quantity? Quantity clearly went up. But look at price here. It kind of looks the same, okay? The way when I draw them, they always end up looking kind of the same. So whichever one sort of looks almost the same, or it's so close, because these are not super accurate, obviously, you know. When it looks like it's, you know, can't almost tell, either it looks like it didn't move at all, or it's hard to tell whether it went up or it went down, that's the one that's ambiguous, okay? So that means that the equilibrium price, you can either put ambiguous or cannot be determined. This is the one that we're not sure of, okay? If we knew more, if we knew that the demand was a bigger shift and the supply was a smaller shift or whatever, then we might be able to tell. But most of the time, you're probably not going to see that. Okay, but sometimes you will, so do be on the lookout for it. All right, so that's what that one looks like. Now let's say that demand increases and supply decreases. All right, so once again, I start like so. Always, always, always. There's my quantity, 1, P1. Okay, so I'm showing supply. I'll start with demand. Demand increases, so what do I do with my demand curve? Shift it to the right, D2. Supply is decreasing, so what am I doing with it? Shifting it to the left, there's S2. So there's my new equilibrium point. Okay, I come over here, D2. That one is clear, so clearly what happened to my equilibrium price? It clearly went up, but look at my quantity. So my quantity, again, ambiguous, because it looks to me, I can't quite tell. All right, and that would change where that Q2 falls would change depending on how far apart I drew those curves. I might get a different answer. Okay, so that means that the equilibrium quantity in this case is ambiguous. Okay, cannot tell. Yes? Everybody follow me? Yep. All right, let's take a look at if demand decreases, supply increases.
Okay, sorry, I don't know why I did that.
Okay. As long as you don't have it. All right, so demand decreases. So what am I going to do with my demand curve? Shift left, there's D2, and we are looking at supply is decreasing, so what do I do with it? Left as well, S2, D2, and S2 meet right there. So one of them is clear. Which one's clear here? Quantity is clear. Quantity clearly did what? It clearly went down, it decreased, but my price is unclear. Okay, and on this it looks like it's the same, but it really isn't, because I just don't know exactly where I should be moving these curves. I'm sort of guesstimating. So whenever I draw them, it always looks like it's kind of the same, but the answer there would be it is ambiguous. And finally, or it cannot be determined. Okay, and then finally, if demand decreases and supply decreases, so I'm going to move them both to the left. Okay, notice again the importance of the labeling with the 1 or 2 or whatever. So if I didn't do that now, I might be putting the wrong 2 together, making an incorrect equilibrium. Okay, so which one here wasn't clear? Quantity is clear, it definitely goes down. Price, ambiguous, because again, it looks kind of the same, but it would depend on, a couple of things that I can't quite show here, or didn't quite show. All right, so that's how you do your simultaneous shifts. All right. All right, so questions on that much so far? All right, so again, you've got it written down there, but I really do think that memorizing it is kind of a waste. Just graph it out. Graph it out. When in doubt, graph it out. I'll always say that. All right, so moving on into another really important concept that we can get from supply and demand, and we're going to keep on seeing this over and over and over again, and that is the concept of consumer and producer surplus. We need to know what consumer and producer surplus are, what that means. We also need to know how and where to find it on our graph, on our supply and demand model that we've been using. Okay, I'm going to point that out to you, and we need to know how to calculate it. All right? Calculations, yay! We're supposed to get excited. We love calculations. Okay, so consumer surplus, it's a little bit like utility, but it's also rather different. But it does have to do with kind of the happy points a little bit. So what consumer surplus is? Consumer surplus is it is the difference basically between what someone is willing to pay versus what they actually pay for something. Right? That's how we could find it. It's the difference in what people are willing to pay for something versus what they actually end up paying. So in that sense, it sort of adds up to the sort of additional benefit, the additional satisfaction that we get when we end up paying less for something than we were willing to, right? So it can be found as it is the buyer's maximum, okay, consumer surplus is CS. It's the buyer's maximum, the consumer's maximum, the highest you were willing to pay for it, minus the price that you actually paid. That's how you would actually calculate it. So it's the maximum price somebody is willing to pay, we call that willingness to pay, minus the price that was actually paid out. So tell me, if you were going to go buy a hamburger this afternoon, what's the maximum price you would pay for a hamburger? $5. Okay? Let's say you go to McDonald's and you pay $2. What would your consumer surplus be? $3. Okay? So it's kind of like utility, and you can sort of think of it as like sort of the additional points, but it is a little different. Okay? If I was willing to pay $50 for a new pair of shoes, and I go into the store and get them for $40, what would my consumer surplus be? Be $10. Okay? Now, if I was willing to pay $50 for a pair of shoes and I paid $50 for a pair of shoes, what's my consumer surplus? Zero. Wouldn't get consumer surplus in that, could be even. Okay? But that's what consumer surplus means. On the graph, okay, we can find this on a graph. Now that's talking about individual consumer surplus. Okay, we have individual consumer surplus, and then there is for the whole market. All right? For the whole market, represented by the people that would have paid more for that good, that were willing to go higher than that equilibrium price, but didn't have to. All right, we put all that together, and that is consumer surplus. When we talk about consumer surplus, assume that you're talking about the whole market, If it says individual consumer surplus, then you're talking about a single person. But on a graph, it is the area beneath the demand curve and above the price. Oftentimes that's going to make a triangle. Sometimes it won't, but for now, they'll probably make a triangle. So it is the area beneath the demand curve and above the price. I'm going to show you that on the graph in just a moment. All right, producer surplus is essentially the same concept, but again, it's applied to the supplier, applied to the person or the company, whatever that is supplying or providing that good. So producer surplus is the difference between what a supplier or producer or seller, whatever word you want to use, the difference between what they were willing to sell something for and what they actually sell it for. Okay, the difference between what they were willing to sell it for and what they actually do end up selling for. So again, surplus, think of it as like the extra, sort of the extra kind of like satisfaction, but that's probably not the best word. It's not necessarily extra money, but it's sort of an arbitrary thing, but still very, very important. All right, we find that, okay, very similar to the definition. Producer surplus, or PS. Notice again, you can have individual producer surplus, but we're talking about for the whole market. It is the seller's minimum minus the price that was actually paid. The seller's minimum, so they have to sell it for at least this much. They will go no lower, minus the price they actually get. So let's say that we are selling t-shirts, okay? And our minimum price is $10. We will not sell those t-shirts for less than $10. And the reason that we're not going to is because that wouldn't meet our cost. Okay, that's why a producer would not do that. If they're not going to cover their cost, they won't sell it. Okay, so our minimum price that we've got to take for those t-shirts is $10. Customer walks in and they're willing to pay $15. All right, what's our producer surplus? It's $5. If we are selling cars and we've got to sell them for $20,000, anything less than $20,000 won't cover our cost, so we are not willing to make the sale at that particular point in time. Okay, so $20,000 is our minimum price. That'd be a deal on a new car. Customer comes in, they're willing to pay $30. What's our producer surplus? $1,000. If they came in, we could only sell for $20,000, and they're willing to pay $20,000. What's the producer surplus there? Be zero. What if let's go back to t-shirts. Okay, I've got to have $10. That's my minimum price. Someone comes in, they're willing to pay $8. What about that? No sale. Okay, no sale. They would not make the sale at that point. Okay. All right. On a graph, graphically, the producer surplus is the area above the supply curve and beneath the price. Area above the supply curve and beneath the price. Oftentimes that's going to make a triangle. There will be times that it won't. And when we put these together, consumer surplus and producer surplus, we get what's called total surplus. So total surplus in the market is when we put both of those together. Consumer surplus plus producer surplus. Okay, so this.
When we're talking graphically, which price is it referring to?
Equilibrium price.
Okay. Yeah.
All right, so we're going to graph this. We're going to draw this in our notes so we know where to find it, okay? So you can go ahead and be drawing yourself a basic model of supply and demand. Put your axes in, put your supply curve, put your demand curve, okay? So we're going to end up with something kind of like that, all right? Now, you don't have to put numbers on yours, all right, this one, but we're going to use this also to calculate, okay? Draw yourself in your notes a little supply and demand graph. Price on the vertical, quantity on the horizontal, upward sloping supply curve, labeled S, downward sloping demand curve, labeled demand. Now again, on this one you have numbers, you don't have to put that on yours. Okay, in this particular situation, what's our equilibrium quantity? Quantity. Quantity is 30, and the equilibrium price? 20, okay? So when we draw that, okay, notice what it kind of did was it made two little triangles here, all right? These represent our consumer and our producer surplus respectively, all right? The area, remember, when we talked about it just a moment ago, you just got to memorize this, okay? You're going to get lots of questions about consumer surplus. Consumer surplus is always the area beneath the demand curve and above the price. Look here, beneath demand curve, above price. Oftentimes making a triangle, again, don't get married to that idea. There will be times where it may not be a triangle due to things we haven't talked about yet, but that is our consumer surplus, all right? And then producer surplus is that. Remember, as we talked about a moment ago, producer surplus is the area above the supply curve, and beneath the price. There's price right there. This wouldn't be it, because it's beneath the price, but it is not above the supply curve, okay? So what this represents here, all this, these are all the consumers that were willing to pay 25, 35. See how they're, they would demand, or for 35, they would still be demanding something here. So that represents all those consumers that are willing to pay more than 20, but they had some kind of consumer surplus because they only had to pay 20 instead of 35 or 30 or whatever. The same thing for our producer surplus. This represents those sellers that were willing to take and able to take a price lower than $20. But because the equilibrium price is $20, they had some sort of extra bonus happy points there, okay? We put that together, and that together is total surplus, okay? If we had to shade, and oftentimes you will have lots of questions about shade the area of consumer surplus, or where is producer surplus, or shade total surplus. That's what you would be shading, is those triangles, if it happens to be a triangle in that instance. Total, of course, would be all that. We can also use this to calculate consumer surplus and producer surplus. Okay, how might we do that if I was going to calculate consumer surplus? I think I calculate what this represents.
Take the price.
What is this shape? A triangle.
Do we have to do Pythagorean theorem?
No, you don't have to do Pythagorean theorem. How do you do area of triangle?
One half base times
Half the base times the height. Okay, so that is one of your geography, oh my God. Geometry, thank you. There was one in geo subjects. Genealogy though. That is one of your, I did it again, oh my God. Geometry formulas that you do need to know, okay? And I think that's the only one. Make sure you know, if you don't know, write it down. The area of the triangle is half the base times the height. Okay, you do need to know that. Half the base times the height. All right, so let's see what's on here. All right, so if we had to calculate that, all right, the consumer surplus at $20. So if the price is $20, all right, what would our, it doesn't matter which one you say is the base or the height, really. So if I'm saying that this is, we'll use 30, okay, that one's easier to calculate. All right, so if my base is 30, I do half of that, which is 15. What's the height here? 15, 35 minus 20. Okay, don't say 35. 35 minus 20, which is 15. What's 15 times 15?
225.
Thank you, 225. So that would be 225. Okay, I multiply that out, that's 225. So $225 is the consumer surplus. That's what that represents. All right, the producer surplus, once again, area of triangle. All right, my base, let's say it's this. All right, once again, what's half of that? Half of the 30? 15 times 10, which is 150. So the producer surplus would be 150. Okay. Total surplus, what will we do? Add the two together. Or if I didn't want to do that, which why wouldn't you? But if you say you hadn't already done that, you could do the area of this whole triangle. Okay. You could do that as well. So 225 plus 100, and what do we say? 150? Is that the last one? Or what do we say?
225.
So that'd be what, 325 plus 50 is what, 375? Yeah. So that would be your total surplus. You put those two together. But you could also get that same answer by doing the area of this triangle. So again, 15 times 35 minus 10 is 25. That would be that. Okay? All right? And we got that right, and that right, and that right. Yeah.
Wow.
That's how you do that. Okay? Really pretty easy. It gets a little bit more complex when the shape starts moving around. But it's still the same thing. It's still the area. It's always going to be the area above the supply curve and that sort of thing. The shape of that can change, but it's just the area of it, which is either going to be a triangle or sometimes it's like a rectangle plus a triangle or something like that. But that's how we find our consumer and producer surplus. All right. So let's see what we remember what's going on. All right. So in this particular model, what is the equilibrium price and quantity? $18, quantity of 20. Okay. Let's calculate consumer surplus. Make sure I don't go too far. Producer surplus and total surplus. Okay. Take a moment and you can talk to the person next to you, Freddie behind you. Do a little scratch work. Let's take about 2 minutes and we'll see what we get.
See, I think I would have to write out. 15 times 15. Yeah, I know. Is it 13? Yeah, I think go above that. I know the 13.
Yeah, when we were doing the ACC practice last year, I have to look that up.
4 is 13 times 13.
All right, ready? We don't even need to. All right, what do you get for the consumer surplus? 40. Okay, it's the area of that triangle right there, which I can either say, okay, 22 minus 18 is 4, half of that is 2, times 20, that's 40, or I can do it the other way around, half of 20 is 10, times 4, there you go. All right, what about the producer surplus? 20. It is found in that triangle right there. This 18 to 16, that's 2 times half of the 20 is 10, thus 20. Or I could have done it the other way around. Total surplus? 60 because it's the 40 plus the 20. Or I could have done the area of both the blue and the green triangles all together. Okay? All right, so that's what we get on that one. Yes? Okay. Okay? All right. Yay for math. We love it.
Yay for math.
I